Hey everyone, coming at you with another video for space design. This time we're going to be talking a little bit about geology and how you're going to be getting samples from Phobos and Deimos into your designed vehicle as per the mission parameters. That's why you're going there in the first place. So a little history, looking back, when the Apollo program was implemented and was occurring, originally, there was no plan for geology. It was just to get there to beat the Soviet Union. As we got closer to actually doing it, however, though, the scientific community was really excited by the prospect of being able to return samples from the moon that could maybe have some kind of bearing on how the moon was formed, how the Earth was formed, and answer other scientific questions of that nature. It's a picture right here of Neil Armstrong. The second he got out of the lunar lander in July 1969 in Apollo 11, the first thing he did after getting off was taking a contingency sample. So this is colorized footage from the descent stage of the LEM. Immediately after he got off, the first thing he did is take a small sample in case they had to abort pretty quickly after. As I mentioned before, it's been well noted that the Apollo astronauts were trained extremely extensively in the scientific geology that their missions would encompass. It's digging, classifying different kinds of rocks, understanding that without a scientist looking over their shoulder to tell them what to dig up, that they could find appropriate samples to bring them back and not waste anyone's time, as well as how to photograph and classify them. Some of the samples they got, or some of the tools they used to get samples rather, on the left is the contingency sampler that I mentioned in that picture earlier. That was used by astronauts immediately when they got off the LEM to get some kind of sample in case they immediately had to abort and go back to Earth. It's gongs, which I thought was kind of interesting. It's a mixture of a scoop and tongs, and you kind of use it with the handle to close the tongs after you got a scoop and only have larger samples make it through those grates on the tong side of things, as well as just a normal scoop. Again, all of this was kind of hard to use on the moon with the lower gravity of the moon, as well as the cumbersome spacesuits. And of particular interest towards our project on the right is the sample return container. These could each hold about 50 pounds or 20 something kilograms of lunar samples and rocks. And to do this safely and make sure they got back in one piece, had a foam lining around the inside, kind of like a Pelican case now. That's something that you might want to look at as part of the requirement for your mission, is to have no less than 50 kilograms of samples from each moon and to ensure that they make it back to Earth in one piece. Here's a set of tongs being used on the moon. There's a scoop being used. And there's a more complicated, kind of like what we're about to talk about with Mars missions, hammer drilling in sample the core a little bit lower below the top soil of the moon and retrieve some of that. And there's one of those lunar sample return boxes, like I mentioned earlier. I'm more recently talking about unmanned missions to Mars. This is a GIF of the Mars InSight lander. It's not a rover, but it's stationary, digging a little bit out of the topsoil of Mars. I thought it was interesting. I always love pictures and GIFs from Mars, kind of fascinating. Here's how both the most recent two Mars rovers, Curiosity and Perseverance, have taken samples out of the ground from Mars. Upon drilling them up, they would place them into one of these sample containers on this carousel. The sample container, because the samples, unlike Apollo, weren't coming back to Earth, they had to have the science be conducted on them inside the belly of the rover. So these samples would, in their containment unit, rotate up into the scientific instruments. So they have a mass spectrometer, They would have helium that would pump through the sample and release different compounds that could then be examined by mass spectrometry or other chemical means to better understand their makeup. And this is a look at one of those sample tubes on Perseverance. some soil in. That's another picture of a similar size sample. And these samples were achieved by, similar to that carousel, a carousel of different drill bits for different tasks. Now, I'm going to have Dr. Gong include a paper that's a really extensive look on different means of drilling and getting science from Mars as we have in the past 20 or so years with different rovers that you can use to, along with this video, inform how your group is going to drill and sample from Phobos and Deimos, retrieve the samples, and bring them back to Earth without having them infected or contaminated, rather, by interacting with the crew. They have to stay and make it back to Earth in one piece. So all these are some things for you guys to think about for the science portion of your mission. Otherwise, without EVAs, this is why you're going to Phobos and Deimos in the context of this hypothetical project. Once again, I can't make my office hours this week. Dr. Dong's filling in for me, but good luck with all your PDRs. And if you need anything, feel free to send me an email. My info is still on the campus page. Another really interesting thing I wanted to leave you guys with that you can look up that's going to be happening within the next 5-10 years is the most recent Mars rover, Perseverance, landed this past spring, has a feature where it can leave tubes of samples that it's gathered on the ground. And the plan with this is to have a fetch rover and a returning rocket that would have those samples be picked up by the fetch rover, put in the returning rocket, sent into Mars orbit, and then sent back to a capture spacecraft around Earth orbit so that we could have samples from Mars back at Earth for the first time. And this is a collaboration going on between NASA and ESA that they're looking to do within the next 5 or 10 years. So that's something interesting you guys can look into as well. Getting the samples back without having a manned craft there as we have in the context of our mission. Once again, good luck with all of your PDRs and feel free to reach out to me if you need anything. Have a good one.